Good morning, ladies and gentlemen. It is my pleasure to introduce Chad Pilkey and not Justin Robinson. Chad Pilkey is a student in Seneca's School of Information and Communications Technology who has been working on the Big Blue Button project in CDOT for since January 2012, and will be speaking to us today about accessibility.
All right, thanks for the introduction. Yeah, my colleague Justin, he's on a bus delayed, so he might be showing up partway through. Hopefully he will. But that's how things go. Yeah, so I'm here to talk to you about accessibility and what I've learned on my project this summer, trying to make the Big Blue Button project accessible. Big Blue Button is an open source web conferencing suite, software suite, and its main focus is distance education, and it can also be used for meetings, both large and small, and one-on-one meetings. It has audio, video, presentations, writing on the presentations, and all those sort of things. Now, to accessibility, try and picture in your mind a website that you use a lot. It could be Facebook, it could be CNN, it could be anything. And imagine all you have is that picture in your mind, and you have to try and navigate the website and go to the different menu options and click on everything and visualize everything in your head. All you have is that picture in your head. What if you didn't have the ability to actually see that screen, or you could only partially see the screen? It would be a lot harder to form that picture in your head and get everything in the right spot and the place, and the visual doesn't matter so much, it's more the content. What if too you had, on that website, you have this tiny little box somewhere on the screen that you have to navigate your mouse to and click it, but you can't move the mouse because you can't move your arms. All you have is a stick in your mouth and you have to tap the keys. That's how you navigate the computer. It's very difficult to use applications both on the web and native. Population of the Earth is almost 7 billion. And it's estimated that between 10 to 20% of those people have some sort of disability that affects their ability to navigate a computer. So that's quite a significant number of users, and in no way insignificant. It's very useful to do these things, or to make your program accessible to people who have difficulties with them, for both ethical reasons and also legal reasons. The governments of the world, Canada being one, have started enacting laws. So if you have the ability to make your program accessible, you have to do so by law. And there's definitely good reasons for it. Our client in Big Blue Button is based around Flex. It's a Flash, was Adobe, now is Apache. It's a Flash framework that allows complex applications. Adobe puts out its own API for accessibility. It's 47 pages long, not a very interesting read, pretty informative. It has a lot of information that they put in themselves, and you just access their API, and it does most of the accessibility work for you. You use their stuff, and it works great. Now, remember the website that you pictured before. It has now the developer has, from the start, developed with the idea that everybody should be able to access their content. It's a lot easier to make your project accessible from the start than take an existing project and then make it accessible, because you've got the framework of your application, and it's not necessarily it's got all kinds of complex movements or things like that. In order to change it, it's a lot more work than if you start from fresh and know your objective going through. One of the other technologies that we used this summer was ARIA. It stands for Accessible Rich Internet Applications. It's the web standard for making web pages accessible to screen readers. It provides things like dynamic content and extra descriptions that aren't visible to sighted users. So you can put in all kinds of extra stuff to explain a picture or to list or label a button. If you have a custom button element, you have to actually set it up correctly so that it's even recognized as a button. Because if you just put a click element on it, the screen reader has no idea and the user has no idea that it's even a button. So you have to label everything correctly and set it all up with ARIA. One of the greatest advantages to ARIA is dynamic content. So the newest step forward in web development is, instead of static pages, pages that change, pages that get in information all the time. So with ARIA you can list or label something as a dynamic area, and the screen reader will keep paying attention to it and get all the updates from it. So you can keep adding information to it and the screen reader will read it out as it comes in. It greatly enhances the ability of the web pages. So here's an example. If you had an alert that was coming up, so you have a message that's coming in, if you have say a stock tracker or something like that, you put in this alert, you say it's polite, and as you add it, the screen reader will read it out whenever it's finished reading out what it was reading out before. It's very useful, very easy. There are some limitations to this technology though. Even though it's fairly simple to understand and implement, it's not always easy to use from a developer standpoint. There are a lot of difficulties. Say you have in Flex, you have built a custom component and you've spent all this developer time building this component from the ground up. You don't then have all the accessibility stuff that Adobe's done on top of that. You have to build in all the Microsoft events to actually alert the screen reader that you need or that you've changed your information. The problems with ARIA is that it's still a working standard. So the user or the working group is changing things all the time. So you could write something now and in 2 weeks' time, it doesn't work. So you have to keep up to date with the things, with the changes coming into the project. So here's some limitations that we found. In Flex, if you have just a label on the screen, and this works in web pages as well, in normal HTML, if you just have a text box, it isn't necessarily read. You have to actually tell the user that it can be read, or you have to tell the screen reader that it can be read. And things like, we had a chat box, and the chat box had, go back. There it is. So we have this chat box here, and each of those items in the chat box is an item in the array, which is just a list of messages. And when it's being put out to the screen, it's just being put out to a plain old text box. So when the screen reader reads it, it reads everything all together. And if the user wants to go back and read the previous message or read the next message, it can't, because it's going to read the whole thing every single time. So we had to devise a way to allow the user to go back and forth within our messages. The other issue that we approached is, because our application is so complex, we have the text from the slides, the text from the chat, we have the audio from the presenter. It's all these information sources all coming in together, and the user has to try and figure it out in their head. So the solution that we came up with was to allow the user to control when they get their information. So we have alerts for when a new slide changes. We have alerts for when a text message comes in, and we feel that was the best way to deal with our issues. All this is great, and you can know all this stuff and all the disabilities and program your stuff great, and it works amazingly when you test it. But the key to all of this accessibility work is that you need to have an actual user who uses this technology. Somebody who's actually a blind user and uses a screen reader all the time, they know how they expect their information, they know how they're going to get it, and if they don't get it that way, it's maybe too confusing to use, and then they don't use your program, they don't use your web page, they go somewhere else. So you have to get real users that know what they're doing, because in 4 months you can't understand how to use a screen reader perfectly. There's no way. There's all kinds of intricacies, and you can change all settings, and there's hotkeys for everything. So you have to get somebody to actually do it. All right, so now I have, because when you listen to a screen reader for the first time, it's very hard to understand. We have some examples of a simple web page and then a complicated web page, and what the screen reader will actually say out to you. This is with NVDA, which is an open source screen reader software. It's not as good as maybe a proprietary system, but it's not thousands of dollars. So this is an example. Can I click on it? I cannot. Here we go. Audio is not hooked up.
Along with a brief explanation written by a professional astronomer. 2012 October 25 link graphic see explanation.
I don't know where it's coming out. That sucks. No. All right. Nothing. Yeah, the one's for recording, one's for the PA system. This one?
Yep.
This one's the recording. Hour. Nope. Okay. That's too bad. That's all right. So this was what you were going to see.
Sorry, Chad. Actually, could you turn the speakers, the volume up on your laptop, and then just take one more shot of it? Like, it's got to be coming out from your laptop somewhere.
It's almost max.
Yeah, that's true.
I don't know where it is, though.
I mean, it's got to be coming out somewhere, and you're, I think,
2012 October 25 the Medusa Nebula heading level 1 astronomy picture of the day. Link discover the cosmos. Each day a different image or photograph of our fascinating universe is featured, along with a brief explanation written by a professional astronomer.
Anyways, it's all robotic, and it's not too clean. It reads out basically everything, so... Now I've messed everything up. Great. It reads out everything. So if you have headings, it'll say heading 1, astronomy picture of the day. All this has is a picture and some text at the bottom. That's it. And even then, it takes a minute to read everything on the screen. Whereas a sighted user just looks at it and you understand where all the important information is, and you can skip through all the stuff that you don't necessarily care about, like the date. You just sort of skip over it. But the screen reader reads everything from the top down. That's the only way it works. And then a blind user has to sort of imagine the picture of what the website looks like or how it functions in their head from what they're given by a top-down website. So if you have all kinds of CSS that moves everything all over the page, it gets confusing fast. So this is just an example of a simple website. And then we have an audio, which won't work, of a complicated website. So this is the Toronto Sun website. This is from yesterday. It doesn't even show everything. I took this picture, I took the screenshots yesterday, and it doesn't even go to the bottom of the page. But when the page loads, the screen reader will read out every single element on this page. So each of these boxes on the screen Each of them is clickable. So it'll say link, where it goes, what it does, and then link for every single box. Whereas you could just say what it describes and say that it's a link, and it gets it all over with. There's much more easier ways to do it. And I didn't go back into the background of how they set this website up, but I can imagine they're using all kinds of complicated, like very in-depth CSS to move everything around the page and form it up the way it looks. The way it comes out in a screen reader is not that way. And to try and make that appear the same with a screen reader, very, very difficult. So if you know that you're going, this goes back to knowing that you're going to make something accessible from the start. If you know that you're going to make something accessible from the start, it's a lot easier to make it accessible than try to take this and make a screen reader read it. There's also another point. Each of the little links, so at the bottom or somewhere on the page, there's little Facebook links. So each of those links, it'll say, like, when you see a page and they say, link this on Facebook or share this on Twitter, each one of those little things is read out constantly. Oh, and there's usually like 4 of them on the page. People don't care. It's just, you got to make it simple. So when we started this project, we had to get into screen readers. We did all kinds of research on the different screen readers. The 2 main screen readers, there's all kinds of them, but the 2 main ones are JAWS. That's the biggest proprietary one. It's $1,000, I believe, 700. So it's not cheap, and it doesn't necessarily upgrade as you go, so you have to keep paying the money to upgrade it to the new versions. And the other one is NVDA. That's what we use because it's free. Works pretty good. We had to find out how a user actually uses these things because we can press a button and read a web page, and that's great. So now we've read a web page. But to actually put it into your head and see how a blind user uses it, we looked up on YouTube, and there's all kinds of videos. But there was one video of a lady who, her desk is just a keyboard and a mouse and some speakers. The monitor is off to the side, pointed in a different direction, and it's really archaic and just sort of there in case somebody else needs to use the computer. It's just a completely different way of setting everything up, and it's very hard to, like when you're actually testing, you have to just turn off your monitor, press tab a bunch of times to go through all the elements on your page and see if it works. You can't have a monitor, and it's difficult. So, not JAWS, but JAWS. Job access with speech. It's the most widely used, not open source. Definitely has the best sound quality. The voice is actually really good. And it has a lot of navigation keys, so the user can only pick out links, or only pick out menu items, or only pick out images and loop through them all. So it has lots of features. So now I'm just going to go over some of the main categories of disabilities that one should consider. And these aren't a complete list, and they aren't the only way that these will, like you can have a blind user who also can't use doesn't have very good motor ability. So they're not singular, they aren't only by themselves. So we have visual impairments. These can include total blindness to full-sightedness. So you could have somebody who needs a screen reader, somebody who uses a screen reader just as assistance, somebody who uses a magnifying program that will magnify the screen. There's also color blindness. A lot of people don't realize or don't consider color blindness. So if you have a screen that has red and green and that's how you do your color contrast, it will just look the same to somebody. But then there's also all kinds of different levels of color blindness, and the easiest way to deal with this is to give the user an option of choosing their colors, or to choose white on black. Just something simple. When you get into the crazy colors, it isn't easy. Justin.
Hello, sorry I'm late.
The other one is dyslexia. So if you have text that is really bundled together and you've chosen a font that's really, really hard to read, not the greatest idea. It's something to consider, and it's a big deal for people who have this. So some things you can do is to set up hotkeys so it's easier to navigate your page, easier to get to the menu, easier to do all those things. Allow users to control their text size, so then they won't need the magnification. If they can choose, if they have a chat program and the text size is really, really tiny, if you give them the option to boost up the size, not too hard to do from a developer standpoint, you just have to do it. And it greatly improves the quality of life. So options to change colors and fonts. And then here's an example of, for dyslexia, there was a study done, and it turns out Comic Sans is actually pretty good for people with dyslexia. The text doesn't usually jump around a whole lot. And it's kind of funny because people usually rail on Comic Sans as not being too professional, but turns out it's actually kind of useful. Do you want to take it?
Yes, thank you. Another category of disabilities that tends to fall within our scope is that of motor impairments. Now, there are a lot of different illnesses, injuries, what have you, that can, thank you, that can produce motor impairments that impair someone's use of the computer. For example, quadriplegia, if your arms are...
There's two of them.
Okay.
They're attached to me, so don't move too far.
All right. I noticed that. As I was saying, people who suffer from quadriplegia, clearly no or little use of the arms and hands, someone who is, for one reason or another, missing a limb or both limbs, muscular dystrophy, ALS, also known as Lou Gehrig's disease, for those of you who don't know, cerebral palsy. Some of these produce weakness in the limbs. Some of them produce severe tremors, as does Parkinson's. Arthritis, as I'm sure most people know, produces severe pain in the joints, which can also make using the keyboard or the mouse very difficult. And that's just scratching the surface, just a few examples. But there are quite a few devices that can help people with these various disabilities to actually interact with the computer. Pictured here, we have a one-handed keyboard designed so that someone who is either entirely missing or just missing the use of their left hand or left arm to be able to use all the features of a regular keyboard. We have the very simple and very simply named mouth stick over on the right. This one has a convenient holder for the user. The end that is in the holder at the moment has a rubber tip, so the person using the stick simply holds it in their jaw and can hit individual keys, move the mouse around, move a trackball. There's also various sorts of eye movement tracking software, very sophisticated, far cry from the mouth stick. Head wands, sip and puff devices, which use airflow, the user's own breathing, as a method of sending signals, such as mouse clicks or keystrokes. And the key point of many of these devices is they either use the keyboard, like the mouse stick, head wand, etc., or they emulate the use of the keyboard, such as eye movement tracking software. These devices often require a lot more patience, as you can imagine if you're thinking right now of attempting to use a keyboard using a stick held in your jaw. They also require a lot more physical effort, such as trying to maneuver yourself so that your head wand or what have you can actually interact with the device that you're trying to use. And in the case of disabilities that include some sort of tremor or spasm in the hands, precision is a big concern. Some of the ways you can plan for this as a developer is put adequate space between certain elements. So the submit and the cancel button, maybe don't have them touching each other. give a good healthy amount of space so someone who is perhaps shaking as they use the mouse or involved in using a head wand or anything else doesn't accidentally click on cancel and destroy everything they've just spent the past hour filling in. Include options such as confirmation for submission of information or deleting information. And give users a way to skip past long chunks of content. For example, if they're a regular visitor of your page, maybe they don't want to see the long graphic that is part of your header, just as an example. Finally, the third category, we have hearing impairments. These range, much like the visual impairments, along a spectrum from total deafness to partial hearing loss. Color blindness and dyslexia should not be here, as they are clearly not hearing impairments. But still, keep them in mind, you know. These hearing impairments don't tend to have as much of an effect on a person's ability to use the internet or use a computer as a motor or visual impairment would. But it does still make certain elements of the internet a challenge. For example, if you have instructional videos or some sort of audio-only podcast with important information in it, obviously someone who is completely deaf will not be able to experience that content. But there is, of course, ways to provide considerations for these users. Make sure any audio content you have on your website or in your application has captions, or at least is clear enough that captioning software or speech-to-text can provide closed captions for the user. Transcripts of audio is also a very good consideration to have. And these can be very inobtrusive to users who don't need them. Just put them on a separate page with very clearly labeled links. And also for users with various levels of partial hearing loss, volume control on any audio elements that you have, and once again, speaking clearly, can greatly improve their ability to experience your content. Have we already covered everything else? Yep. All right. Thank you for your attention today. And if there are any questions, we'd be happy to field them. Yes?